Hi, I am Mahindra Kodimale from Government Engineering College, Chamarajanagar. Today I am conducting webinar on SWDTM 2019 software. So in this webinar, we are discussing about SWDTM and its installation and how it works and how do we use it. Okay. So this software is SWDTM means its full form Softwel Digital Terrain Modeling. It's a modeling software. Okay, it's a just a plugin which is used with AutoCAD. Okay, developed by the Softwel Private Limited. The software features a user-friendly interface for plotting survey points and generating contours. It's a plugin for AutoCAD. It's a external software which can be attached to the AutoCAD. DTM is used to create contours. Okay, this software is used to create contours, plans, ground profiles like cross sections and L sections, longitudinal sections. Collectively, it's called digital terrain modeling. Okay, creating contours, plan, ground profiles, collectively called digital terrain modeling. Okay, okay. This SWDTM software is used with AutoCAD. Okay, AutoCAD is a commercially computer-aided design and drafting software application. We use it to create the plans. Okay, we using it for drafting, called creating plans or sections or 2D drawings, and it also capable of generating 3D, but most probably it's used in 2D workspace. Its productivity can be best utilized by using plugins like SWDTM. Okay, AutoCAD, apart from creating plans or sections, we can use it for multiple purposes. Okay, for that we have to install some plugins to extend its productivity. Now move on to the SWDTM installation. You just need to Google it. Okay, as a SWDTM, you will find a web link called Softwel like image shown below. Okay, like this you will find an Google link in after the search result. You will find a web page like this. You will find softwel.com.np download software. Click on this link. Secondly, you will be redirected to the Softwel Private Limited's website, official website, and then go to the download section. After clicking in this link, you will be directly redirected to the this link. Okay, this web page. After coming here, just click on download software in green button. After that, your software will be downloaded. Okay, then if you are using Chrome or browser, just click Ctrl J. You will find downloaded software. Okay, SWDTM with specific version. Okay, like this. This is my browser, and you can see SWDTM. My presently installed or downloaded version is 6, SWDTM 6 with specific file type .zip file type. Okay, after clicking here, you will find the downloaded software here. Just go to shown in folder. Then after reaching here, just click on right click, then click right click, then click open with whatever the file manager available. Just click with open with it, then click extract. Okay, extract to the required location. Then after the extraction, you will find setup.exe, a file, executable file like this. Just double click on this. You will find an installation button, a button called install. Okay, Then after clicking the installation button, the installation will be completed within a minute. Okay, after the installation you will find a icon like this. Okay, this icon you will find, then click on it. Okay, before beginning of the installation, just make sure your AutoCAD software is running in the background. Okay, just open it, minimize it, then proceed on the installation. Okay, I hope you will install it. Okay, so I am moving on. After the installation, just click on the software, whatever the icon you are viewing. Icon will be automatically comes to the desktop after the installation. Okay, okay, now you can find this this is the SWDTM software which is linked to AutoCAD. Now, okay, on successful installation, plugin window shows up as below. Installation of the plugin, your window shows up like this. Okay, this is the window I am talking about. From now on, you can use this software for topographical works, mapping, or creating sections or contours. Okay, before moving to the actual use of SWDTM software, we have to understand what if there is no SWDTM software, what the problems or what are the challenges you are going to face. Okay, so I am beginning with some few examples or exercises. So for the first exercise is understanding how to draw contours. Okay, how actually we draw. Okay, so if you are if you are drawing a contours in an area of 30 by 30 meter, we are then going to divide those total area into number of segmental areas. Okay, we are creating grid lines, drawing grid lines and making some those total area into small areas. Okay, after that so how we dividing it, we dividing in equal interval. Okay, say like 5 meter or 10 meter, depends upon the area. Okay, so uh, less interval means more accuracy. Okay, here we are dividing in with the interval of 5 meter. Okay, yeah, in every 5 meter we are drawing vertical and horizontal lines on the ground. This is just assume this is the ground. Okay, these lines are called grid lines, and this point where the grid lines are meeting is called grid points. After that we are placing a leveling staff on these grid points. After on the leveling staff we are taking uh, readings, then we convert those readings into RLs depending upon the benchmark by HI or rise and fall method. Okay, we know in the survey. After we getting RL, then we do interpolation for drawing contours. Okay, basically what the contour is the imaginary line which is connecting equal RL of points. Okay, okay, if for example for the interpolation I am taking here considering only 4 segments. Okay, if this grid points have if these grid points have this RL. Okay, if these grid points have this RL, then we will just assume we are calculating 106 RL. Okay, we are searching for the 106 contour here in between them. Okay, then what to do next? Just observe here, 106 RL should be within this limit. This cannot be here. 106 RL should be here. Okay, it should be available within this limit. So we are considering, okay, here calculating manually. We consider every grid lines connecting each grid points, and then we run calculations for each line. Then after that we mark the point, then connect the points. Okay, that's called contour. We connecting. Okay, so to do that, to mark that point, we just need to interpolate. So the interpolation goes like this. Distance x means, if we are considering 2 points, 106.5, 105.2, here the distance x is from the higher RL. Okay, from higher RL we are taking or calculating the x distance. Okay, now this calculation is like 106.5 higher RL, highest RL, minus required RL, which is required 106 RL is required here. Okay, then 106.5 minus 106 divided by highest RL minus lowest RL. Okay, just we are considering this line. Okay, if we are going to consider this line, whatever the points here, we do the calculation based on the RLs. Okay, if here is 107, then we put 107 as the highest RL. Here is 106.5, same point, so we just do calculation for this point, then we take access from this as well. Okay, here after doing the calculations like this, then multiplying with the interval d, distance. What's the interval here? Here interval is 5 meter. Okay, after the calculation we get 1.92 meter. This 1.92 meter from here, highest RL. 106 RL is 1.92 away from the highest RL. Okay, after this interpolation we get x point, then we mark it, then here also we mark it, then connect. After this connection, that connected line is called contour. Okay, so imagine if we are going to do like that, interpolation manually, writing manually, connecting, how much time will it take to cover all these grid lines, grid points, or drawing different contours? Okay, this will take a minimum 1 hour of time. Okay, however, whatever you do, you use Excel, whatever the calculation method you use, this will take minimum of 1 hour. Okay, so the best solution is using external softwares for this purpose. Okay, you just need to apply some common sense basic calculations to do this. Okay, you know how to install the software, how we do contours manually. Okay, next, with this software, if you get total station data. Okay, if you do surveying, imagine if you'd have done surveying and you got total station data. Okay, total station data will be in Excel or it may be in CSV format. Okay, then how to do it? I will show the demo, just observe it. Okay, this is the Excel. Just open a blank Excel. Okay, opening the Excel, click on data. What we have to do now, we are just opening an Excel. Then we have to import the data from the total station. Okay, total station data is saved in the CSV format in this computer. Okay, then I am importing that total station data into this Excel. To do that, to import, just going to data and get external data from text. Okay, after that I am selecting uh, the total station file. Okay, I have told total station data will be available in CSV or Excel. Here we got in the CSV format, so I am importing it. If we got Excel, then we just open and copy the data. I am importing it. Okay, after this just click on next. Then we are getting a data like this. We want this data in column wise, so here after the every entry we can see comma, so I am selecting delimiters as comma. Then you can see the data is sorted into columns, number of columns. So I am clicking on finish. Okay, okay, asking for the existing worksheet. Okay, existing worksheet, or you can go with the new worksheet. So this is the new sheet, so I am clicking on the existing worksheet. Click on the where you want to insert the data. I am clicking here, then click OK. Okay, to use this data, using this data, if you want to do contours. Okay, this is actually contour data. Okay, done with the total station. If you want to use this data and draw a contour in this software in AutoCAD, then you need DTM like this software. Okay, just to select all the data, then click on copy, minimize the Excel. Okay, then open AutoCAD. Then open SWDTM. Here there are many options. Now I am going with every step you need to do to create contour. Okay, you need to click on points, then you have to import it. Okay, import points from Excel. We have from data from the Excel, so just click on import points from Excel. Whatever the data you copied here, is saved in the clipboard. Okay, clipboard of the computer. So after importing import points, after clicking in importing points, those clipboard data will be imported to the AutoCAD software. Point label scale. Okay, you can give whatever the label scale you want. I am go with the 0.1. Import points. Okay, if that closes, import points window closes, it means that the data is successfully imported. To search that data, to locate that data in the software, click on Z, enter, then E, enter, zoom, extend. You can see this is the contour data now imported successfully. I think it's the benchmark. Okay, this is the benchmark and this is the contour area. Okay, then after this you need to process the points. Process, select all, select feature layer, select all, then click OK. After the processing of the points, you will see how many points the software is processed. Okay, how many points here. After that, just to draw a boundary. Okay, add a boundary. Okay, upon adding the boundary, you need to do triangulation. Click on triangulate, triangles and triangulate. Now the triangulation is completed. Now you just need to do contour. Draw quick contour. What you are finding here is the contour interval. What is the contour interval you want? And major contour. Contour, I want contour interval of 0.5 meter. Then the major contour should be 1 meter. Okay. Upon clicking in draw, the contours will be automatically drawn here. Okay. Okay. This is linking this DTM to this data. So it's drawing contours to this also. If you don't want it, you can trim it here. Okay. So this is how much easy you can see here. Now here you are seeing gray lines and colorful lines. This lines indicating minor contours. These lines indicating minor contours and this line indicating major contour. Okay. After that, you can see the contour RLs by just putting a contour annotation. For that, just go to contour, then click on contour annotation. Okay. Then click add. Click wherever you want to insert the annotation. You can see annotations like this. You can do here also. Some errors will occur like this. You just don't need to worry. Just to open it again. Go to contour annotation. Click add. That's it. Click here. Okay. With this data, you can see this RL is in the higher elevation and this RL is in a lower elevation. So this is forming like this is looks like a heap. Okay. From here it going downwards. Okay. This looks like a well. Okay. Clicking deleting this and I'm going with another data. Okay. I'm going with another data set for the example. Click on data, get external data from text, inlet and import. Next, comma, next, finish. Okay. This is what happens if you don't add boundaries. Okay, previously after the adding the boundary it also occurred, but just I am doing it by adding boundary once again to see the difference. Okay, just copy points, import points from Excel, import points. Okay, points imported, draw, add boundary for the boundary. Okay, previously we imported the points, after that we processed it, after that we added boundary. From in this example we are just importing points, after that we added boundary, then we are going to triangulate it as for processing. Okay, then we click yes. I think after adding boundary, if we click on process, it will process only these points, neglecting these points outside the boundary. So let's see what happens. 54 points selected. Triangulation. After that, I am going to draw contour. Contour. You can now see the contours have been drawn to the what is called contour data. Neglecting this point, its contours are drawn only to the specified points within the boundary. To this, you can add contours into annotations with the required scale, text height. Okay, you can vary here, vary it here. This that's all for this. This this method is useful when you have contour data in Excel format, which is imported, not important, which is exported from the total station. Okay, suppose if you are doing uh, if you are not doing it with the total station, if you are not doing block leveling or contour, okay, it contour with the total station, then how to do it? Drawing contours for block leveling data. If you are using theodolite or dumpy level, whichever the leveling instrument available in your work area. Okay, usually every work area, every field survey engineers use the total station. Everywhere the total station is extensively used. But if you are from college, okay, you are doing it with the dumpy level or orthodolite, whatever the instrument is available in your college, then how to do it? Like doing contouring for the surveying camp usually happens in the 6M of video. Okay, if you are doing it with theodolite or dumpy level, then if you find difficulty, as we discussed in the manual interpolation and then drawing it. Okay, so to make it simpler, okay, to make it simple, uh, contouring or drawing the entire contours using SWDTM and AutoCAD software, you just need to convert the manually taken points or calculated RLs into predefined format for the SWDTM. What's the predefined format? Okay, by using SWDTM you save time. Okay, and it will be a lot easier when compared to drawing it manually. So to do this, you just need to convert it to the format. What's the actual format of SWDTM software uses for creating contour? It's just like this serial number. First comes the serial number, then X distance, then Y distance, then RL. RL is the elevation. Okay. To convert level book data to this format, we just need to set X and Y coordinates to every grid point. Follow next slides. Okay. Here, let's assume this point. This point is the origin. Okay. This here is 0, 0. AutoCAD, you can say this is the origin. Now I am just giving margin from 5 meter from the every side. Here 5 meter, from here 5 meter. Okay, here 5 meter, then here 5 meter. Then this point will be 5, 5, then whatever the RL it is. Okay, just like this. You can see here the whatever the data is available visible here. First one is X, then second one is Y after the comma, then third one is Z. Z means the RL of this specific point. At this X, at this Y distance, the Z RL is available. This point is available. We are telling the SWDTM software that in this 5 meter from X, from 5 meter from Y, we are having ZRL. Okay. Same goes like for every data point. Okay. This is the grid point. This is grid point 2. This is grid point 3. For every grid point, we have some X and Y different values. Okay. For you can see in this example, this is the Y distance, this is the Y distance, this is the Y distance. Y distance having constant value. Okay, this line is having constant Y distance. From here you see the X distance is varying. The first point is 5 meter. From here, the second point is from 10 meter from here. The third point is 15 meter from here. Okay, like that the X value is varying. Okay, now this line have X value same as this points. Okay, this point have same X value as this point have same X value as this. Okay, same. Okay, but the Y value varies only once. Okay, for this line we have constant Y value. Here the Y value is constant, 10 meter, 10 meter, 10 meter, 10 meter, and the same goes for every point. Like this, we just input X, Y and Z data for every point. Then we just add these data into Excel, like entering, for example, just I will do this 3 points in the Excel. Okay, like this. This is the first point. First we have X 5 meter, then we have Y 5 meter, then we have Z RL called 100, for example. Second we have serial number. Okay, just 4 is enough. Next we have X value. Next to grid point is, this is the next grid point. Okay, so the next grid point is 10 meter away from the X. Okay, then Y is 5, then 100 or 99, the RL, whatever the RL is. This is benchmark. You can leave empty in the remark value or the cell. Okay, just to input the single data in the first cell and then leave all the cells blank. It doesn't matter. Okay, then x value is 15, then y value is 5, then the RL, and same goes for the rest of the things. Same goes for the rest. Okay, after that, if we are going to enter this grid point value, then we have to just change. Then the next grid point value is y is 10 meter. Okay, this is x is 5, then y is 10, then whatever the RL it is 99. Okay, this is example. I am just considering 4 points. Okay, from the x to I am just considering 4 points. After that, for this grid point 10 10 and z. Okay, 10 10 and z. For this, the x value changes, x value repeats. Okay, copy. I can here copy paste the value, and here I can just simply drag here like this. Okay, then I can enter the RLs like this. Okay, you can see the demo here in AutoCAD. I'll just delete it. Open the software, DTM, import points from Excel, making sure it is copied from here. Yes, it's copied. Then import points. The points have been imported. Okay, here with AutoCAD. Import points. Okay. We can see here the points have been imported. Okay, here 5 meter away from here, 5 meter from here. Okay, this is 5 5, this is 10 5, this is 15 5, this is 20 and 5, this is 5 10. Okay, this is 10 10, this is 15 10, this is 20 10. Then you can do whatever you do with the total station data. You can do whatever you want, like you are doing it with the total station data. Okay, after that, triangulate, select all. Okay, triangulation complete. Okay, here the point is 99 and 100. Okay, we can have minor contours here. Okay, draw contours, draw quick contour, 0.1, 0.5, draw. Okay, okay, thank you. This is what I wanted to share with you guys. Okay, I have shared my knowledge, whatever I know, I shared it with you guys. I hope this webinar or seminar helped you a lot. You just learned new some skills or something new you have learned. I hope you learned something new. Okay, so I want to know how you feel about this webinar. Please visit this link or scan the QR, and please give me the feedback, whatever you feel, whatever you want to say, or whatever the suggestion you want to give. Please fill the feedback form and send it to me. Thank you.